Today's topic is quotients of square roots, and today is April 28th. This is the note packet you'll need for today's lessons. There should be 3 pages. Let's go through the steps that are involved in the dividing process. The first step says, if you have numerical coefficients sitting in front of your square root radical, we should actually divide those. Or if it appears to be a fraction, we want to reduce the fraction to lowest terms. Then we're going to move on to the radicands. If you can divide the square root radicals, we will do that. If that can actually happen, the result of the division will still be in a square root radical, but we will place that answer in the numerator. Just to let you know, sometimes division won't be possible, and we don't want to have a decimal contained underneath the square root. One of the steps involved sometimes is called rationalizing the denominator. We'll talk about that in a minute. And then finally, we want to simplify our square root radical to lowest terms if we can. Now, dividing doesn't always follow these steps. They like to deviate. You just have to know what to do in each situation. Keep in mind, you need to show all of your work in the division process. Let's start with example number 1. What I see here are numerical coefficients of 8 and 4 sitting in front of the square root radicals. So I'm going to start by dividing, and that will give me 2. And then I also can see the square root of 48 will divide by the square root of 2, leaving me the square root of 24. So both of those can be divided, and this is the result. The next step is to simplify if we can. So if you can multiply any two numbers to produce 24 and there's a perfect square in there, we need to divide that out. So I'm going to use the factors of 4 and 6. The square root of 4 is a perfect square, so it turns into 2 times 2. And then ultimately we'll multiply those together, and the final answer is 4 radical 6. This problem did follow the rules that we just saw on the last slide. Now, if we rationalize the denominator, what it says is that I can see there's a square root radical in my denominator, and I need to convert that into a rational number. We are not allowed to leave a square root radical in the denominator, so whenever you see one present, this is the process that we'll go through to eliminate it. So in example 2, I have a fraction 25 over 3 being square rooted. The first thing I'm going to do is separate this into 2 distinct pieces, a numerator and a denominator, both of which, though, have a square root around them. Now the numerator I recognize as a perfect square, so in my next step, I am going to simplify that. But according to the rules, I'm not allowed to have a square root of 3 in the denominator. So this is where we will rationalize. We're going to multiply by the square root of 3 over the square root of 3. This is a version of 1. No, we're not going to cancel anything out. We're going to multiply 5 times radical 3, and then in the denominator, radical 3 times radical 3. So that will give me 5 radical 3 over radical 9. In the final step, radical 9 can be converted to a rational number, and that's the number 3. Now at this point, if your fraction 5 over 3 could reduce, you would actually go through and reduce it one more time. But for this problem, we have gone through all the steps, and it's as simple as possible. Number 3. What I see is there are no numerical coefficients to reduce or divide. So I'm going to go ahead and start with the rationalizing process. I cannot have radical 8 in the denominator. So again, this is a version of 1. We're going to multiply by radical 8 over radical 8. In the numerator, we have 1 radical 8. It's okay if you don't write the 1, but in the denominator, we have to multiply that, and it's radical 64. I do recognize that as a perfect square, so my final answer is 1 radical 8 over 8. Number 4, I do have numerical coefficients 3 over 6. This will not divide and get the number 2, but it will reduce to the fraction of 1/2. So I'm going to go ahead and reduce that. I also can see that radical 45 will divide by radical 5, and that will reduce this automatically to 1/2 radical 9. Now I recognize 9 is a perfect square, so I'm going to convert that to the whole number 3, and then I'm going to multiply my answers together, and my final answer is 3 over 2. You can make it 1.5, but I like the improper fraction the best. In example number 5, this is very similar to a previous example. We're going to separate this into 2 distinct pieces. However, I already know that 20 will simplify. So I'm going to start that process. So 4 times 5 would produce 20. I'm going to leave radical 7 as it is for now. In the numerator, I will simplify to 2 radical 5. But again, I'm still stuck with a radical in the denominator. So at this time, we're going to rationalize. We're going to multiply by radical 7 over radical 7. And I'm always using the value in the denominator when I set up this variation of 1. In the numerator, we're going to multiply 5 times 7 to get a new radical of 35, and in the denominator, a new radical of 49. And then the radical 49 will simplify to the whole number 7. My fraction of 2/7 will not reduce, and this problem is all set. In number 6, again, I have a full fraction underneath the square root radical. I'm going to separate this into 2 distinct pieces. So I have radical 3 over radical 4. The nice thing about this problem is radical 4 is a perfect square. So I'm going to simplify first, and by doing that, there is no longer a square root radical, and this problem is done. Number 7 is a little bit different. We're including a variable. What I'm going to do is separate the numerator into 2 distinct radicals. So we have radical 9 and radical y, and it's over the square root of y. What's nice about this is these 2 factors are identical, and they'll cancel each other out, leaving me just radical 9, and that's a perfect square, resulting in 3. For our final problem, I can see that 71 will not divide evenly by 2, so I'm going to start this process by rationalizing. So we'll multiply by radical 2 over radical 2. This will change my numerator to the square root of 142 and the denominator of square root of 4. At this time, you should check to see if the square root of 142 will break down. I do know the denominator will. And after checking, the square root of 142 does not have any perfect squares that can be removed. So we've simplified the denominator, and this problem is in lowest terms. We're going to skip these examples. I think we've already done a fair number of examples to give you a good variety. This will be homework number 114. There's tons of white space around this work, and there's some on the back. You're going to do all 20 problems. Make sure you show all the simplifying that's involved in this process. If you don't, I'll know that the calculator cheated for you, and we don't want that. If you have any questions while you're going through the homework, please make sure you contact me so that I can give you some help. Otherwise, have a great day.